Today we're going to be talking about properties of logarithms. Starting off with your state standards, below that is your success criteria. To be successful today, you need to be able to evaluate logarithms. You need to be able to expand or condense logarithmic expressions and explain how to use the change of base formula. All right, the first thing we're going to look at is your properties of logarithms. Remember, logarithms are inverses of exponential functions. So we've already learned properties of exponents. When you're multiplying the same base, you add your exponents. When you're dividing with the same base, you subtract your exponents from top to bottom. And when you have a power raised to a power, you multiply the powers. So we're going to use these. If you have these committed to memory, it will make your properties of logarithms a little bit easier. All right, so properties of logarithms: let b, m, and n be positive real numbers. B cannot be equal to 1. All right, so your product property, if you have log base b of m times n, product, remember, m times n, then that's going to change to log base b of m plus log base b of n. So your product property tells you that you can rewrite it with addition, okay? Same thing over here. If you're multiplying, you change that to addition. All right, your quotient property. So your quotient property, log base b of m divided by n, that's going to change to subtraction. So you can rewrite that as log base b of m minus log base b of n. So again, division, your quotient property means divide. That goes to subtraction. And then your power property. So your log base b of m to the n power becomes n times log base b of m. So the power comes out front and becomes the coefficient. So that one's a little bit different. But those are the three basic properties of logarithms that you need to commit to memory, or at least be able to look at these and understand what to do to rewrite them if you need to use your properties of logarithms. One more property that you need to know is your change of base formula. Logarithms with any base other than 10 or e can be written in terms of a common or natural logarithm using the change of base formula. This allows you to evaluate any logarithm using a calculator. And you're going to see a couple different ways to use your calculator to evaluate logarithms. But change of base formula, you can use basically any calculator. You don't have to have a TI-84 to use the change of base formula. For some calculators, it doesn't have the log base button where you can actually put in different bases. So in that case, this would be very handy. But this is also one of the state standards, is you have to know the change of base formula. So regardless of what kind of calculator you have, this is an easy formula to learn, and so we will be going over that. Basically, if you have log base c of a, you can rewrite that as a different base, log base 10 or e. Remember, if we're changing it to natural log or whatever, so b usually will be 10 or e when we use change of base formula, but it doesn't have to be. But if you have some base, log base c of a, you can rewrite that as log base b of a. Okay, that's your number here. And then log base b of c, which would have been your subscript. And hopefully these will make more sense when we look at some examples, because just looking at the formula tells you what to do, but it kind of doesn't really help you see what we're talking about just yet. Example 1, using properties of logarithms. Use log base 2 of 3 is approximately 1.585 and log base 2 of 7 is approximately 2.807 to evaluate each logarithm. All right, A part says log base 2 of 3 divided by 7. So here we're looking at a quotient of a logarithm. Remember, a quotient of a logarithm says that we have to subtract. So using our properties of exponents, we can say this is going to be approximately, trying to make the squiggle lines instead of the equal sign. So we're going to have 1.585 minus 2.807. All right, so that's going to be about it's going to be about negative 1.222. All right, so we could actually done that without our calculator, but when it says evaluate and it already gives you approximations, basically you're just using your properties of logarithms. So remember, a quotient means you have to subtract. Here we have log base 2 of 21. This gives us an approximation for log base 2 of 3 and log base 2 of 7. Think about 21 as a product of 3 times 7. So the first thing we want to do is rewrite this in terms of something that we have. So we're going to rewrite 21 as 3 times 7. Then think about properties of logarithms. All right, if I'm multiplying, that means I'm going to rewrite it with addition. So I'm going to rewrite this as log base 2 of 3 plus log base 2 of 7. And then we can use what we are given up here in order to get an approximation or an answer. All right, so log base 2 of 3 is 1.585 again. And then we're going to add it this time to log base 2 of 7, which is 2.807. And that's going to be equal to, or approximately equal to, 4.392. All right, one more example, log base 2 of 49. All right, again, 49 isn't up here, but 49 is 7 squared. So again, before we get started, we can rewrite this as something that we do know. So let's rewrite this as log base 2. Instead of 49, let's rewrite this as 7 squared. Then remember your properties of logarithms. Okay, if it's a power property, that means the exponent will move to the front of your logarithm. And that's just using your properties of logarithms. So I'm going to move the 2 to the front, and it's going to become 2 log base 2 of 7. All right, now log base 2 of 7, we're already given an approximation for. It's 2.807. So we're just going to substitute that in here. All right, so we have 2. That's part of the, I want to say equation. It's not really an equation. It's more of an expression, but we're going to have the 2 come down, and then log base 2 of 7. We're going to replace that with 2.807. And that's going to give us 5.6 something. Let's see, 2 times 2.807. 5.614. So this one's going to be 5.614. All All right, so you can see that using your properties of logarithms, sometimes you have to rewrite these first based on what you're given. But using your properties of logarithms, this is not very difficult if you just use your properties of logarithms. Common error, note that in general, log base b of m divided by n does not mean log base b of m divided by log base b of n. So remember, the quotient property did change this to subtraction. Multiplication changed this to addition. And the power property brings the power down front as a coefficient. So you have to know those properties or you will not get correct answers. Example 2, expanding a logarithmic expression. All right, so we're going to use our properties of logarithms to expand this time. So when I look at this, I've got 5 times x to the 7th divided by y. So I basically have 3 terms here. I've got the 5, I've got the x to the 7th, and then divided by y. So let's think about what our properties of exponents do. So the first thing we're going to do is use the quotient property to add subtraction in here. When I say add subtraction, I just mean rewrite it using subtraction. So we're going to say this is equal to log. We're going to use natural logs this time. So natural log of 5 x to the 7th, and then minus log of y. So again, that's just taking this division, rewriting it as a logarithm, and using subtraction. That's the quotient property. Then I have a product property. I've got 5 times x to the 7th. So we know that that is addition. So we're going to say ln 5 plus ln x to the 7th minus ln, which is our natural log, y. All right, one more property can be evaluated. We've got x to the 7th power. Since we have a power, remember we can rewrite that, we can bring that down as a coefficient. So what I'm doing is using all the properties. I'm just evaluating one property at a time. So we've got log of 5, natural log of 5, that can't be reduced anymore, and then plus 7 log of x minus log of y. So when it says to expand, that just means your properties of logarithms, use those to expand as far as you can. Example 3, condensing a logarithmic expression. All right, so example 2, we expanded. Example 3, we're going to condense. So we're going to use the exact same properties, but now we're going to rewrite it in a smaller term. So condense means make this expression as small as possible. So instead of having the log of 9 plus 3 log of 2 minus log of 3, we're going to condense it so it looks something like this. All right, so using the properties of logarithms that we just learned, the first thing we can do is say that this plus will make this multiplication. So let's say log of 9, and then it's going to be times, and then we can go ahead and write this as a power. So we know this is going to be 2 to the 3rd power. So using another property, this is going to be 2 to the 3rd property. All right, now we have minus log of 3. Let's just go ahead and bring it down just like it is for now. All right, now we're going to evaluate. So 2 to the 3rd power is 8. So we've got log of 9 times 8 minus log of 3. And then 9 times 8 is 72. So we're going to have log of 72. And that's divided by 3. And the reason it's divided by, remember, quotient property. So now I'm going from subtraction to division or quotient because we're condensing. We're using the properties to go in the other direction. And then 72 divided by 3 is 24. So log of 24. So if we condense this expression, it is equivalent to log of 24. So again, example 2.